Well, hi, good morning, and thank you for joining me here in my shop. Today is June 13th, and the rain has gone by. Some sun is shining, but boy, it's cool outside today. So, what have I got here in front of me? So I've got a radio in front of me that does not work, doesn't really work well at all. Has been heavily modified by a previous person, rebuilt completely. I don't mean rebuilt to what it was, but rebuilt into a new kind of radio. And the result is, with the radio not working, let me change that sentence. That was a bad start. So with the radio not working properly, I have to ask myself, what is the issue with it? Is it that the fellow who did all this work made mistakes in what he did? Or he tried something that is only going to perform poorly anyway? The very best you'll ever get out of it is poor performance. And by the way, in case you haven't watched the other videos, what was done to this radio is the original 1 volt tube. Okay, they're actually supplied with 2 volts for the heater, but they're commonly called 1 volt tubes or battery radio tubes. They're all pulled out, 6 volt tubes put in, and a 6 volt transformer added, and also a high voltage transformer added, and a high voltage rectifier power supply added, and a few components changed. And as I noted yesterday, a number of wires have been relocated. It's hard to say how many, but this really doesn't have the look of a factory build like this wire right here, which has a short extension on it. Eventually we'll be looking at this closely, I'm pretty sure, because this extension says something. It says this wire never went here in the first place, and to get it to where it goes now, the fella had to extend it with a little 1.5 inches of wire here. Where the wire went before, I don't know. I don't have a schematic for this radio, which is another challenge in working on it. I almost said frustration, but I think challenge is a better word. And so, it could be he made mistakes. I made mistakes. His original attempt was faulty. Like swapping these tubes, that's a huge... I would never even try it. I would never ever try it. Far too much work. Far too much risk of complete failure. Now the owner of this radio said he was able to pick up some stations on broadcast. And when the radio first got here, I'm pretty sure once or twice I picked up a broadcast signal. But with a good antenna. But at this point, with me having changed a couple capacitors, and just like for like, three capacitors in fact, the radio's performance appears to have gone downhill. And now it's not receiving anything other than noise and stuff. Still has an effect. If you do something to the antenna, you hear something out the speaker, so there's something going through it. I took a look at the local oscillator situation using my SDR radio as a spectrum analyzer, and what did I see? When you set this knob to shortwave, you see an oscillator frequency very close to what it should be when the radio is in broadcast. That's pretty weird. What it looked like on the SDR was, I put this into broadcast mode. We see the local oscillators somewhere on the spectrum analyzer. When I flipped to the shortwave, it just moved a touch. Not much at all. As for a local oscillator being present when at a higher frequency, when the radio is set to shortwave, I couldn't see or find any local oscillator where it should be, regardless of where the radio was tuned on shortwave. That's really weird. Even though when you flip it to shortwave, you have a local oscillator within the broadcast range, you don't hear anything. Assumably, some coils have been switched for shortwave purposes, so even though the local oscillator is kind of in AM position or broadcast position, nothing's getting through the radio, probably because it's being filtered out by the shortwave front-end tuning stuff. Or really? Is that really what's going on? I got no idea if that's what's going on. So my next best move with this radio is to check and adjust the alignment in it. Just on AM. I can't do anything on it on shortwave, really. Not without a local oscillator. That's very, very mysterious. Now what would prompt somebody to do those things? Not the tube stuff, but to fool around with the wires in here. This is what's going to affect the local oscillator. I'm pretty sure these are the oscillator coils here. And this would be the antenna coil. It looks like wires on the switches here have been changed. They just don't look like they came from the factory here. Generally, wires coming from the factory are not kinked left and right, left and right, left and right. See how this is kind of waving along through here? This one not so much, but even this one has bends and waves in it. Generally speaking, they're putting in a straight piece of wire and running it to where it's going. And this is only, radio number 1000 where the person has done it. And that wire gets laid in and it stays straight. Yeah, okay, they bend it around something, but all those bends make sense. This is all bent in here. This red one's all bent here. They're all bent, and none of it makes sense why they would be bent the way they're bent. Unless somebody removed the switch. They put in a different switch? I don't think so. I can't be sure of anything, but they put in a different volume control here. I think there's a good chance of that. The tone control, by the way, is just a switch on this radio. It doesn't have a rotating control like the volume control here. And this volume control, I don't know if you can hear it, but you can definitely hear something going on inside it, and it sounds like a wire rheostat is what it sounds like. So the slider in there is bumping over the wires, bump, 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 making that sound. That would be odd. That would pretty much say there's been a replacement done here. So, as I said, alignment is the name of the game. Okay, I just needed to review all that and make sure it's clear in my head before I do the next step, in case there's something I haven't thought of. But if there is, I still haven't thought of it. Okay. By the way, when I'm doing this work, even though I might, and certainly at the initial stages, or I might be making statements about this, that, or the other thing, turns out down the road this, that, or the other thing are all wrong. I know that at the start, that anything I'm concluding, I can't conclude. Not at the start, because you don't know enough about what's what. So, in the early stages, I may say things, and I'm still kind of in the early stages here, unfortunately. I may say things which you may recognize as being false. Another thing I do is, in the early stages, to reach a conclusion, I don't take it very seriously. So I'm not going to jump up and down. I'm not going to worry if I've got a little wrong, because I know down the road more puzzle parts are going to come forward, and the picture is going to clear up. And if I've got it wrong, I'll get it right down the road. So, there's a video being shot here. I'm saying things. There's something here to be adjusted. What is this? I'm saying things, but I may not be characterizing them in terms of what is that? It's over here in the corner. Well, it's a capacitor up in here. It's kind of an odd spot. And there's this odd creature here also, which looks like some kind of capacitor. I'll have to look at that a little closer, but there's a capacitor here, and so there's 1, 2, 3, 4 more capacitors down here, which you can get at through the. Wow, that's a lot of stuff to adjust without instructions. That's a lot of stuff. That you can't be guessing at it, or you can't expect a good result if you're guessing at it. Can I put this over like this? Go. Okay, so what we're going to do is we're going to run a frequency through the radio called the IF frequency, the intermediate frequency. The way these radios work, super heterodyne radios work, is they receive a signal at a certain frequency, and then they convert it down to a specific frequency, 455 kilohertz. And then a good deal of the radio, all this stuff I'm holding here, is set up to be tuned to that one frequency. This is great. That means as you tune the radio, you continue to put the one frequency through here. Everything that's tuned here can just be left as it is. In the front part of the radio, where before the frequency's been converted down to 455, everything has to tune with the tuning of the radio. Well, and sometimes everything is really just one stage or one thing. That's what's going on here with this part of the tuning capacitor. It's just tuning the one thing. And some of these radios, they have more sections in their capacitor. They have more things being tuned ahead of the conversion to the intermediate frequency. Some radios have very little tuning in the front end. Cheap radios have very little tuning in the front end. Okay, having said that, and it could be some examples right there of things I'm saying that aren't really true, either generally or specifically to this radio, but what does it matter? In here are two capacitors, one here, and there's two more over here. Inside the can are two coils. The coils are arranged close enough that they act as transformers. And the signal is fed into one of these coils and is transformed into the other coil, if I can use it that term. And then it heads out into this tube, gets amplified. The signal sent into one of the coils in here. The signal is transformed into the other coil and heads out to the detector tube, which I'm not going to talk about. When it comes out the end of this one, I'm pretty sure it's this one here, it's a strong 455 kilohertz signal. When it goes in at the very start, it's the radio frequency you've tuned to, 680, whatever it is that you've tuned to. This tube is doing the conversion from the tuned frequency down to the intermediate frequency. And it's the local oscillator signal that helps with this process. And so what you're doing is you have an incoming signal, and inside this tube you mix it with this other signal, the local oscillator. And you see the distance between my fingers? That represents a difference in the frequency, assuming this is like a spectral display here. And that difference, if it's 455 kilohertz, this guy can hear it. And it's going to go through the radio, come out the speaker. Everything else, rejected. As you move the local oscillator, move it down here, well, now the spread is small. The frequency created by mixing these two together is nowhere near 455. It can't go through the radio. But guess what? There's another signal down here, and when you've moved the local oscillator this far, if it should happen to be 455 between them, coming out the speaker. And it could be also 455 up this way. So when you're trying to tune this frequency and you move the local oscillator until there's 455 in here, coming in, the radio is now sensitive to any signal that happens to be 455 kilohertz up here. But other tuning factors in the radio will try to reduce this other signal, called the image signal. And on an AM radio, the image is generally way out of the band, way out. Not so with shortwave though. Okay, that's kind of a rough explanation of what's going on here in the radio. Now, I want to make sure that this part, the intermediate part, is properly tuned to 455. I'm assuming 455, did I see it somewhere? I thought I read it somewhere. probably on the schematic for the similar radio. 455 is a very, very typical frequency for these. Could be 460. You know, could be 270. Not likely though. Whatever it is, we should be able to detect it by feeding signals through here until we hear it come out of the speaker. Then we'll know what this is tuned to. That's the first step. Okay, and I think I'm going to stop for a little bit, and I'm going to get all the equipment set up and turn the cameras back on, and we'll do the process. Okay, first challenge is, where am I going to pick up the signal? I'm going to display it on my oscilloscope up here, but I have to pick it up from somewhere in the radio. Usually, a good place to go is on the volume control. Because at the volume control, there's often the output, that's a good place to go. The input to the volume control. But, you know, if I had a schematic, I would check and see. I have no schematic. So we'll take a look at this. Volume control. This is the output from the volume control on this shielded cable. Shielded cable is grounded here. This is the input end to the volume control. So at this point, there's a good chance that the entire output of the IF is sitting right here. If we look, we can see this wire, which again is another wire that just doesn't look correct. It's hidden behind here perhaps for you. You can kind of see it. It ties right onto one of the terminals on the second IF transformer. So for sure, it's all coming out and it's going over here. Now this is a small, I don't know what this is. This is a resistor or a capacitor. You know, I'm too stupid. Looks like a resistor to me though. Resistor here. There should also be a capacitor trying to quell the high frequencies. Here it is. This capacitor up here. You can see that one right there. It's tied to the same terminal as this wire. Okay, so this wire is going to still be carrying some RF. I'm really not interested in the RF, come to think of it. What I really want to see is the DC voltage that's created by the detector. The detector is the tube that follows the second IF transformer. That's where this capacitor is heading. That's not quite making sense. Oh, I can look down in here, I can see all kinds of little wires that the guy has added to it. So, and just more evidence that what I believe happened did happen. That is, all these tubes got changed. Well, we can just check this out. We can just try it. So, with any luck, the AVC voltage is sitting here, which is really what I want to say. Put that on the scope. To put that on the scope, we would put that like that. I'm just practicing right now. Then we just hook that on there. We're on the scope. Okay, now do I want to put this underneath the radio? I like to have the radio sitting down when I do this. I can just bring out a clip lead. Okay, we will bring out a clip lead. Clip this here. Maybe not. I can't really clip it down there. Yeah, only one spot here. Green clip lead is the AVC. Okay. So what we'll do is we'll take, well, we won't do it right away. We'll get ready. So that's what I'm going to put on the scope here to cause a vertical deflection. The horizontal deflection, which is normally generated internally in the oscilloscope is going to come from the sweep generator I'm going to use to sweep a signal through here, and we're going to look on the scope and see what we get. You know what, that's really kind of the second stage, come to think of it, because we don't have any idea what the IF really is here. I'm just guessing. I think it'd be better to fish around with this signal generator first and try to hit the mark. Okay, so that's what we'll do. We'll start with this. We'll do that sweep thing maybe later. That's a little more of a complicated test. Okay, so we still need so now we need an input location, because I can hook up a voltmeter to this too if I want, rather than the oscilloscope. I can watch the ABC voltage go up and down. What do I need here? I need a clip lead. Okay, now we need a place to put the signal in. In this radio, I could probably get away by just sticking it into the antenna, but I think a better place probably is into this spot here. I could even pull this off and stick it right into there. Be amplified by this tube and shot in there. We'll do the least. Let's do the least approach. The ground on. The least being leaving the radio in its normal state as much as possible. This is a low impedance connection to the signal generator. Probably going to kill any signal that might be coming in from the antenna. I don't have an antenna connected anyway, so probably it's just going to overwhelm it more or less with the signal coming from here, which we need that switched on. We need to switch on the radio too. Let's do this with a voltmeter first. So I'm going to utilize this meter here. I already have one ground lead put on the chassis. That's where the grounding's happening. So this guy's going on the chassis too. It's going to go in the same spot. This lead, yeah, I'm going to want to clip this on here. But again, we're going to do it while the radio is operating, so I can tell, just in case what I'm doing is disturbing the radio. Okay, we should turn this guy on, let him warm up a little bit. Volume is there. Everything's okay. Good. There we go. So we're going to let this guy warm up. I don't have my... This is a really handy thing. Get something like this, run around your house, plug stuff in, plug your vacuum in here, find out how much power it really draws. Very handy device. I normally have it plugged in down here, but it's just a place where it lives. But, okay, does it work? Okay, it's working. Now let's just check a couple things, and I'm going to go have some coffee. Let's just see. So the meter here is set to go up on a negative voltage. There should be a negative voltage here. There it is, going up. Excellent. This voltage should change as I tune the radio a bit. Good. Okay, a terrible sounding radio for sure. Really terrible. We're going to leave it like this, let it warm up, and I'll be back pretty quick, just a couple minutes. Okay, first cup of coffee done. I usually have 2 cups of coffee. Here we go. So, what should happen here, if this radio is working fairly well, I should be able to dial in 455 here. And we should hear something come out of the radio. Ignoring all the funny sounds right now. Let's just tune this a bit. That's pretty interesting in itself, right there. A rumbly sound over here. Pretty silent over there. So that, I think, is this. This is at 685. This is dialed up to about 710. Well, that sounds pretty good. Okay, so this is quite certainly the signal generator. This is probably a noise. Let's see if I tune this away. So because there's a tube in here that's mixing frequencies, and theoretically all it's mixing is what's coming in on the antenna, a range of frequencies, and a single local oscillator frequency, it should be only casting out 455 once for every station over here as you tune. But throw in a pile of noises, noise signals, and you can get quite a schmozzle coming out of that. That's what I think. That's probably what that is. That's part of the schmozzle. That's pretty good there. But that's not what we want. We don't want to listen to that. We just want this in a quiet zone. Anywhere down here is going to do it. And we want to dial this down to that 455 and see what happens. We got a pretty strong signal. Let's see. Here we go. $620. This thing was, wow. Okay, don't know what to make of that. Right, there were, no, there's only one. Yeah, okay. We're getting close now. Here we go. That was it. What do you do with that? There should be a nice pure tone there. So I'm flipping the modulation between 400 and 1000 hertz. And that's what you hear coming out of the radio. Oh boy, it's a serious problem. This should just be a nice pure tone here. This shouldn't sound like a transport truck engine. Let's see what's happening on the meter over here. I'm just going to move it over this way. Okay, trust me when I tell you. Okay, so that's going back and forth through the that IF spot. Nothing happening on the meter. It's stuck here. Okay, let me turn up the signal a little bit. Turn down the volume. This shouldn't happen with the volume control. Okay, so let's watch this meter now and listen. Okay, so there's a pretty good peak right there. I'm going past it now. And we get this other thing. Okay, we'll stay away from the other thing. Go back here. I like that. Okay, we're gonna declare this to be the actual IF frequency. Let's see, look what it is. 452 on my machine. But you can add 1 to this to make it more accurate. 453, just shy of 455. That's pretty good. That suggests that whoever fooled with this before had the instruments like what I have to do this kind of test and set these correctly. So I'm going to try touching them up now because it's just possible they really aren't correct. They could still be. So you're trying to line up four things, okay, and it's their average that you'll kind of hear the result of. So if you have them all lined up, you get the strongest result. If you have one a little off, things are weakened a little bit and broadened out. But if they're all off like this, you can get an effect that produces a fairly reasonable response curve in roughly the right place, but it's not nearly as strong as it could be because these are like this. You gotta get them like this. So we're gonna get them like that. That's what we're gonna try to do. So the way to do this, I may get my hand in front of the camera here. With with this set to the proper IF, which is just up a wee bit. There it was. There's hardly any difference in watching this meter, and now adjust these capacitors. Ooh, what's going on there? So I'm using a metal screwdriver and it's not working out. Sometimes it does, sometimes it doesn't. We'll get a plastic one here, or a different one. What about this one? Okay, it doesn't do the same thing. I'm not exactly sure what was it in this one it was doing. What was this one? Oh yeah, as soon as I touch this capacitor, I have a plastic hand. The problem with this is it probably won't sit in the slot of the screw. There's a flathead screw in here. This is too wide. Okay, hold on. We have more options here. Okay, take this tool. There's just a little bit of metal. Watch the meter. I'm trying to get it to go as high as I can. That was a touch higher there. There we go. So we got a little more out of that one. So we're just making that little adjustment. Okay, we're in. Watching now. This table doesn't rotate. Going down and going down. So this one was right on the money. Okay, go to this one here. I like to spit on things before I work on them. Here we go. Right on the money. Oh no. Oops. That's way off. So the problem with using the plastic tools is they twist. They develop a certain amount of energy in them. I don't know what else to call it. Twist in them. The screw sticks a bit. When the screw finally gets enough pressure, the springiness, the energy stored in here will cause the screw to jump. And you just jump. Meanwhile, you really want to just be doing it smooth. That's why I like the metal screws. Was I over here? Where was I? I don't even know where I was now. Let's do this one. Another thing is, the radio itself has an automatic level control or volume control. We don't actually have to listen to this. Level control working in it. And as you raise and lower the signal strength by adjusting these, the AVC is countering what you're doing. So if you notice, sometimes the meter, when I'm doing this adjustment, will come up quite high and then relax back. That's the AVC causing it to relax back. That can cause a lot of confusion when you're trying to do this, which is why they say you don't want the AVC activated while you're doing this. It just makes it more difficult. But you know, if you're smart, it's just, oh, look at that, which is, here we got one, which is my shortfall. Oh, that one was way out. That was out quite a bit. That was out quite a bit. Now normally we run through them again. Just checking, we're still at 455 on the signal generator. Okay, got a little more of that. The thing about aligning these is you can get them all lined up perfectly, but they're over here and they should be here. So that's another thing that can happen. They give you the impression that you've got it right and you're doing this without instruments. 8.5 is possible. Oh, this is just terrible. The springiness is just terrible in these tools. I mean, it wouldn't matter if the screw wasn't resisting, but there's a lot of resistance in the screw. 8.5. Well, maybe it was 8.5 with the AVC. Yeah, that's as high as it's going to go there. Okay. Here. Got a little more to that. And this was the one that was most off. Now this was not seriously out of tune. Even though I can get it a little bit better. Oops. Ooh. There we go. Okay. Is this going to make a dramatic difference in the operation of the radio? No. But we need to check it now. So we're going to take this off. And leave this meter connected. It's not doing any harm to the radio. We need to put an antenna on it. I think I may have turned off the antenna. Well, that's not a good sign, is it? That's not a good sign at all. Okay, so I had this, without realizing I had this on shortwave, which really doesn't matter. Let's go back here. Shouldn't matter. No antenna. Okay, the antenna goes on. Oh boy, that's going to work. Quite a squawk came out of it there. Is she squawking? No, it's just extremely sensitive. Come on, radio. I have to go and check and make sure the antenna is switched on. The pointer actually comes above the plate here. Okay, what's happening there? Sounds like somebody's talking through their hands and then doing this. That's the sound I hear. She's close to breaking into oscillation, is what it is. This radio's in big trouble, boy. Did I do it? Big trouble. Big fat trouble. Okay, a couple more things before I panic here. We'll hook this up to the ground. See if we can get something now. What just happened? There was a little click and the radio's performance changed entirely. Let's see, where's the magic stick? Who did it? Something happened there. What happened just now? Oh boy. What happened? I do have a clip lead underneath the radio. Still getting a little bit of a negative voltage here. Oh! Well, wow. Okay, so it sounded to me like I just tuned this up. The radio broke into an oscillation. Perhaps one we can't hear. We don't hear the whistle from it. And this has made the radio very, very sensitive because of the regenerative effect. That's what I think's happened. Let's tune this down, see if it quits again. I don't think so. Okay, so that effect is not there right now. Get my hand on the volume control because I know what's going to happen here. It's going to pop in right there. And then it's popped out right here. In, out. You can watch the action here too. Oh my gosh. Oh, let's take off some stuff here. Not that this should. I think it's still popping in and out right here. Hard to say. Lots of weird stuff going on. Let's get these other grounds off of here. That one will make a difference. Last ground off. Okay, leave the volume alone. That's definitely got that sound to it. So this kind of behavior, when you've changed the components and in a normal radio with just normalness, not this one, it can normally has all the original. No one has altered the radio dramatically like this. And I forgot what the point was I was going to make. Oh yeah, when you start hearing stuff like this, you got to start thinking that a mistake was made in the radio. That maybe if it was a radio I was working on changing the capacitors, I've gone and hooked one up wrong and it's causing this kind of thing. Because this is a dramatic problem. And if we put the ground on, it changes dramatically too. A lot of drama here. Well, that's dramatic. This radio's just got a mind of its own. Definitely something happens right in here. Stop the oscillation. Start the oscillation. What's going on over here? This has just gone away. Oh, I took the ground off. That's why that's doing that. You can really hear it. Off here, on there, off here. Okay, you know what? I'm going to stop at this point, and we will pursue this tomorrow. It'll give me today to think a bit about how to do this, how to look for this kind of problem. Maybe if I had a schematic, I could work my way through component by component and try to find something. The impression I have is the person who worked on this made some significant changes to how it's wired underneath also. I think we've seen a lot of it. And the result of that is the radio's not working. I mean, if my theory is correct, somebody tried to change this from a battery radio to a plug-in radio with 6-volt tubes. That's a huge undertaking. That's a design the radio again situation. Unless there was an article in a magazine that he followed, which is not very likely. This is just one radio. why would somebody write a magazine article about one radio? Somebody could write a magazine article about how to do this generally, but that wouldn't help you specifically with the model of radio you've got in front of you. And you know what else I just noticed? I'm hooked up not to the outdoor antenna, I'm hooked up to the antenna behind me. Oh, okay. The loop antenna. Yeah, I'm not going to get anywhere here. Well, you know, just for the sake of doing it, because how many times in my life have I done something thinking, oh, that can't happen, and then it does. And you go, wow, I just didn't think it could work that way. So we've got to make room for discovery. Now, again, I don't know that this is switched on. So now we're on the outdoor antenna. I have to go throw the switch for the antenna here. I'll be right back. Okay, let's see how this does. So that rumbly noise is good. That's an interference signal that's always here. All kinds of radios pick it up. You can actually see the oscillation come and go. Come. Go. Computer's running low on storage space. That's what I just got a warning, so. Okay, we've seen it. We've seen it under all circumstances. Thank you very much for watching, and I'll be in here again tomorrow. We'll try to look more closely at this, and I have to think of how to do it. How do you pursue this? No schematic. Radio's a one-off. Oh boy. See ya.